Mastering Fine-Pitch PCB Assembly, an exciting journey, Winnow. In this video, we'll take a look at the process of fine-pitch PCB assembly, the benefits, the challenges, and the best practices. By the end of this article, you'll have a better idea of how to tackle the task and get the results you're looking for. So, let's get started. Introduction to Fine-Pitch PCB Assembly. Fine-pitch PCB assembly is the process of soldering components to a printed circuit board with a very small pitch, the distance between the pins. The components used for such assemblies are usually surface mount components with very small pitches, typically ranging from 0.4 mm to 0.2 mm. The process of fine-pitch PCB assembly involves the use of special tools and equipment, such as a microscope, tweezers, soldering iron, flux, and solder paste. The components have to be carefully placed onto the board and soldered in place. It requires a high level of skill to ensure that the components are properly soldered and that there are no shorts or other defects. What are the benefits of fine-pitch PCB assembly? The biggest benefit of fine-pitch PCB assembly is the increased reliability of the board. The smaller pitch of the components allows for increased circuit density, meaning that more components can be placed on the same board. This means that complex circuits can be built into a much smaller space. The smaller pitch also allows for improved electrical performance as the components are placed closer together. This can be useful in certain applications, such as high-frequency circuits, where small components are required. The smaller pitch also helps to reduce costs as fewer components are required for the same circuit. This can lead to savings in materials, labor, and time. Challenges of fine-pitch PCB assembly. The main challenge of fine-pitch PCB assembly is the precision required to ensure that the components are properly soldered. The pitch of the components is so small that it can be difficult to properly position the components without the aid of specialized tools. The components also need to be positioned accurately to ensure that no shorts are created between the pins. This requires a high level of skill and precision and is not something that can be done quickly. The process also requires a steady hand and good eyesight. The components can be very small and the soldering must be done with care to ensure that no damage is done to the components or the board. Essential tooling and equipment for fine-pitch PCB assembly. The most important tooling and equipment for fine-pitch PCB assembly is a microscope. This is essential for accurately positioning the components on the board and soldering them in place. It is also important for checking that no shorts or other defects have been created during the soldering process. A soldering iron is also necessary for the soldering process. This should be a high-quality soldering iron with a small tip, as this will allow for more precise soldering. Flux, solder paste, and tweezers are also important for the assembly process. The tweezers are used to pick up and position the components on the board before soldering. The flux and solder paste are used to ensure that the components are properly soldered to the board. The step-by-step process of fine-pitch PCB assembly. The process of fine-pitch PCB assembly is quite complex and requires a high level of skill and precision. Here is a step-by-step guide to the process. Prepare the board by cleaning it with an appropriate cleaner and applying flux if necessary. Place the components onto the board, using tweezers to position them accurately. Apply solder paste to the pads on the board. Place the components onto the solder paste using tweezers. Place the board in a reflow oven and heat it to the appropriate temperature. Inspect the board for shorts and other defects. Repeat the process until all the components are soldered in place. Common issues in fine-pitch PCB assembly and problem-solving strategies. One of the common issues in fine-pitch PCB assembly is shorts between pins. This can occur if the components are not properly positioned on the board or if the soldering process is not done properly. Other issues include incorrect orientation of components, incorrect soldering temperatures, and insufficient soldering paste. These issues can be avoided by ensuring that the components are properly placed on the board and that the soldering process is done correctly. If any of these issues are encountered, it is important to take corrective action immediately. This may involve soldering the components again or replacing them if necessary. Tips for improving efficiency in fine-pitch PCB assembly. To improve efficiency in fine-pitch PCB assembly, it is important to use the right tools and equipment. A microscope is essential for accurately placing the components and checking for shorts. A good soldering iron with a small tip will also help to ensure that the soldering process is done correctly. It is also important to ensure that the components are properly placed on the board before soldering. This will help to reduce the chances of shorts and other defects. Finally, it is important to use the correct soldering temperature and amount of solder paste. This will help to ensure that the components are properly soldered to the board. Best practices for fine pitch PCB assembly. The best practices for fine pitch PCB assembly include the following. Use the right tools and equipment. Ensure that the components are properly placed on the board. Use the correct amount of solder paste. Use the correct soldering temperature. Check for shorts and other defects after soldering. Take corrective action immediately if any issues are encountered. By following these best practices, you can ensure that the process of fine pitch PCB assembly is done correctly and that the results are of the highest quality. Quality assurance and testing procedures. Once the fine pitch PCB assembly is complete, it is important to ensure that the board is up to the required standards. This can be done through a number of quality assurance procedures, such as visual inspection, electrical testing, and functional testing. Visual inspection is important for checking for shorts and other defects that may have occurred during the assembly process. Electrical testing is important for checking that the electrical performance of the board is up to the required standards. Functional testing is important for checking that the board is able to perform its intended function correctly. Conclusion. Mastering fine pitch PCB assembly is a rewarding and exciting journey. The process involves precision soldering techniques and the right tools and equipment. The benefits of fine pitch PCB assembly include increased reliability and improved electrical performance. Quality assurance and testing procedures are also important for ensuring that the board is up to the required standards. With the right knowledge and practice, anyone can become an expert at fine pitch PCB assembly. Visit our website, WinNowPCBA.